So given 2 points on a line, 11, -4, and -4, 5, find the slope of the line. That's our first step here. So to find the slope, we will take 5 minus -4 divided by -4 minus 11. I'll go ahead and label these points, x1, y1, x2, y2, and that comes out to be 9 over -15, which reduces to -3/5, reducing that by 3. All right, there's part 1. Find the slope. The point slope form. I'm going to go ahead and use the first point. I'm actually going to settle on that one for this portion. So 11, -4, and a slope of -3/5. Y minus y1, so this will be y plus 4, equals -3/5 x minus x1, which happens to be 11. Right. For part C, we want to find the slope-intercept form. So we're going to rearrange this equation, distributing that. It's -3/5 x plus 33 over 5, y plus 4, and subtracting 4. Just go ahead and write that. I'm distributing that. Subtracting 4, that would be 20/5. 20/5. So that would be 13/5. And that will be y. So that is our equation in slope-intercept form. Okay. Example 2. Jessica leaves her house at 5:50 a.m. and goes for a 9-mile run. She returns to her house at 7:08 a.m. Answer the following questions, assuming Jessica runs at a constant pace. So first, describe the distance in miles she runs as a linear function of her time. So we actually want an equation that is d of t equals something in terms of t. Now, to do that, we need to look at the 2 points we have. It's not obvious we have 2 points, but at time 0, 5:50, that's her start, she has gone no distance. Okay, so at time 0, her distance is 0. Now, for the 7:08, okay, at 7:08, by that time, she has run 9 miles. And that is actually 78 minutes. Going from 5:50 to 6, that's 10 minutes. From 6 to 7, 60 minutes plus 8. So that'd be 78 minutes. So our distance, actually our slope, let's find our slope here. That is 9 minus 0 over 78 minus 0. So our slope is 9/78, which reduces to 3/26. 3/26. Now the y-intercept is actually 0, 0. It's the origin, because at time 0, the distance she's traveled is 0. Now to sketch this graph, I draw this very roughly. It goes through the point 0, 0, and has a slope of 3/26. So it increases 3 in the y direction. That's the change in y. The change in x is 26. So there is our function. Really, it's restricted t greater than 0 because we're not too concerned about that. But that should be the graph of that equation. All right, example 3. Oh, not yet. Interpret the meaning of this slope. What does it mean for her distance function to be 3/26 t? Well, that means that every minute, okay, because we are talking miles divided by minutes. Okay, our y is in miles, or our dt is in miles, and our time is in minutes. So this is actually miles per minute. So that slope means that she is running at a rate of 3/26 of a mile per minute. Now, at the beginning, we assumed that she was going to be running at a constant pace. That's where this came in.